Hello, my name is Robert Hart, and I'm a student at Penn State University, Berks campus, currently studying fluid dynamics. I am also an amateur astrophotographer, so I'm always looking for ways to apply what I'm learning in class to expand my understanding of the cosmos, including our closest star. The Sun is composed of superheated ionized plasma, which acts as a fluid and is greatly influenced by the intense magnetic fields generated within. This interaction between magnetic fields and electrically charged fluids is called Magnetohydrodynamics, and the Sun is the largest such system available for study, although it is not yet well understood. Solar eclipses offer a rare opportunity to view the upper layers of the Sun's atmosphere from Earth. Scientists hope to get a better look with the Parker Solar Probe, which launched earlier this year. As you probably know, a total solar eclipse was visible across the US on August 21, 2017. While total eclipses happen somewhere on Earth about once a year, the chances of the moon's shadow falling across land, much less an accessible area, are quite low. As such, I wanted to not only watch the eclipse, but image it as well. Imaging a solar eclipse involves solving many challenges. The Sun is a tiny target that is constantly racing across the sky, and is very dangerous to cameras and other optics. Specialized equipment is necessary for optimal results. A long camera lens can work, but for best results, a telescope is the way to go. It is completely safe to look at the eclipse during totality, but during the partial phases, a solar filter is necessary to protect your equipment. A sturdy tripod will do, but a properly aligned astronomical mount is designed to counteract the Earth's rotation, keeping your target centered for hours. The results were better than I was expecting. This is called the diamond ring effect. It occurs just before and after totality when the last direct ray of sunlight flares around the moon. This image is taken at the same part of the eclipse, but at a much faster exposure time. The edge of the moon blocks the last bit of sunlight, but a few rays make it through the mountains and valleys at the very edge of the lunar surface. The red glow is the chromosphere, and you can also see prominences, which are loops of plasma trailing thousands of kilometers away from the Sun's surface and are created by the Sun's magnetic field. These are images of the corona itself, taken at progressively longer exposures. The corona has a very wide dynamic range, which is impossible to capture in just one image. You can see the inner corona becoming overexposed, while more detail is revealed further away. To create a final definitive version of the corona, we use a technique called HDR compositing, in which several images of varying exposure are condensed into a single image. The program simply cuts the parts out of each image that show the most detail, discards the over or underexposed parts, and stitches the results together. It takes some practice, but the final result makes all the effort worthwhile. Thanks for watching. Feel free to contact me if you have any questions.